Hello students, welcome back for today's lesson. I'm your facilitator for today. My name is Jenaevans. On today's lesson, we are about to discuss an interesting topic known as sets. Immediately I talk about sets, you've given a smile since you have an idea on sets. Without wasting my time, let's look out for the definition of sets. A set is defined as a collection of objects of the same kind. Its objects are called the elements or members of the set. Then, let's look at the ways of writing sets. 1. By description or using the set builder notation. How is it done? Example, A is equal to curly brackets, first four odd numbers, or Q is equal to X is such that X is greater than 1, less than 6. X belongs to N. Let's go to the second one by listing its elements. Examples, A is equal to curly bracket 1, 3, 5, 7. Those are the elements or the members of A. The second set, Z is also equal to curly bracket 2, 4, 6, 8, 10, 12, close curly bracket. Let's go to the third way of writing sets by using a Venn diagram. Example, D is a set. It has the elements or the members 1, 7, 3, and 5. The second set, which is G, has the members or the elements 4, 2, 3, and 5. If then, set notation and description. How is it done? In your previous lesson, that's JHS, you tell me the types of sets, isn't it? If that's the issue, then let's see the first one and let's talk about it. Set notation and description. The first one is what we call the empty or the noun set. What is an empty or a noun set? This is a set having no members. It is denoted by empty curly brackets or a O with a slash, meaning an element X belongs to or is a member of the set T. X, Y, A, we can write it as S belongs to T. The third one, that's the unit set. What is a unit set? This is a set having only one member. Example, set B is equal to 1 in its curly bracket. The second set, G is equal to 0 as its member or element. The fourth one, equal sets. What are equal sets? Two or more sets having the same members, which may or may not be listed in the same order. So what are we trying to talk about? Example, D is equal to 1, 2, and 3. These are the members or the element belonging to D. What of the other set, F? It has 3, 1, 2 to be its element or members. Comparing these two elements, you could see that they all have 3 digits. But for the first one, which is set D, is well arranged. That's 1, 2, and 3. For the second set, which is F, it begins with 3, 1, and 2, meaning it is not listed as the same or as compared to D. But at the end, the members of set D is the same as the set F. So therefore, we will say that they are equal sets since the members are the same. The fifth one, subset. What is a subset? We will use this scenario, or this scenario will help us for we to get to know what a subset is. Set P is a subset of Q if every member of P is a member of Q. It is denoted by the symbol C. But remember, anytime you see the symbol C between two sets, telling us that it is a subset. The sixth one, universal set. Universal set. Before we take the definition of a universal set, already in our various homes, we have a unique charger we use in charging our phones. That's the universal charger. You will tell me this charger is a unique one, meaning it can charge most of our phones. So that idea or ideology that we have, universal set 2, is what? Let's see. In other words, that's what we used to say the mother set, meaning is the set containing all the elements being discussed. It is denoted by the letter E. So all the elements that we will get or which will be given to us, if we want to look out for, most of them or all of them are found in the universal set. So in other words, it's the universal set that gives birth to the individual set being discussed. The seventh one, complement of a set. What is a complement of a set? The complement of a set A is a set of all elements in the universal set which are not elements of set A. So in other words, for you to get the complement of a set, take that particular set being given to you and subtract it from the universal set. The set of, let's say, A being subtracted from the universal sets, the other members or elements which is not found in the set A becomes the complement of A. Once again, if you want to find a complement of a set, subtract or take that set, subtract it from the universal set. The members that are not found in the set becomes the complement. Example, we have these members to be the universal set. We have 1, 2, 3, 4, 5 as our universal set. And set A is 2 and 3. How do we get the complement of set A? It simply means that the members in set A, which is 2 and 3, is subtracted from 2, 1, 2, 3, 4, 5 from the universal set. Meaning, at the end, the complement of set A is going to be 1, 4, and 5. Since the elements 2 and 3 of set A is subtracted from the universal set. If that's the issue, let's go and solve 2-set problems as we used to do in JHS. Before we start with this, we have a nice Venn diagram. And what does it mean? We could see A, B, R1, R3, R2, R4, then E on top there of the rectangle. What does it mean? E is the universal set, meaning R1 plus R2 plus R3 gives us E. That's the universal set. Remember we said universal set is a set in which all the members of the individual set is brought under discussion. What does R1 stands for? Meaning region 1. It is denoted by A intersection B complement is equal to A only. So which means in region 1, that's R1, the members or the elements that belongs to only set A. When we go to region 2, is denoted by A complement intersection B is equal to B only, which means that members or elements that belongs to only set B. R3 simply means region 3 is denoted by A intersection B, meaning the common elements or members that can be found in set A and also in set B. Region 4 is denoted by A union B or complement, meaning members that are either A nor B, so which means members or elements that do not belong to set A or set B is written at region 4. That's R4. Let's proceed. Since we've got to know the tutorials of the set, then let's have a practical idea about it. How is it solved? Question number 2 set problem. Question number 1. In a certain school, 40% are in the hockey team and 70% are in the football team. Each student is in at least one team. Find the number of students who are in both teams. I take it once again. In a certain school, 40% are in the hockey team and 70% are in the football team. Each student is at least one team. Find the number of students who are in both teams. How is it done? Let's see. First of all, we write our solution down. In set problems, or in solving problems in mathematics, the first thing that we need to do is that we write down the datas, meaning the information given to us in the question. These are the things that we need so that we'll be able to analyze or solve our problem. So without wasting my time, students, let's go and start. Now, we said let E, that's the universal set, into brackets, student in the school, and E, meaning number of students in the school, is equal to 100%. Remember, in our question, we were not being given the total number of people or students in the school. But since the number of students in the hockey team and the football team was given in percentage, which means out of 100, then the total number of students in the school will be equal to 100%. That's why we have NE is equal to 100%. The second one, let H, meaning students in the hockey team, NH is equal to 40% as prescribed in the question or from the question. Let P is equal to students in the football team, NF is equal to 70%. So at the end of the day, we have students that they are in the football team and also the hockey team as well. But we're being given the students in both teams? No. So therefore, we use a variable like the way we always used to do in class. Let X is equal to students in both teams. We said E is equal to 100%. That's what we have there. In our Venn diagram, that's in a rectangular box, we have A to be at the left-hand side, which is 40%. F, that's 70% at our right-hand side. Since we are saying let S be the intersection, we want to know students that belongs to both teams or they play hockey and also football at the same time. So therefore, remember we said to be able to find for region 3, that's R3, we need out of region 1 and region 2 to be able to get region 3. So therefore, it's going to be 40 minus X. Our S comes, then 70 minus X. When we subtract from both two sets, at the end of the day, we are going to get the students that belongs to or that are in the hockey team and also the football team. So therefore, our equation is going to be 100 is equal to 40 minus X plus 70 minus X. Once again, 100 is equal to 70 is equal to 40 minus X plus 70 minus X. 100 is equal to 110 minus X. X is equal to 110 minus 100. X is equal to 10%. Meaning, our negative X plus X is equal to 0. Why are we saying this? From algebra, we always used to know that when a variable stands on its own, it has a coefficient of 1. So negative 1 plus 1 is equal to 0. So which means negative X plus X cancels out for it to get 0. When we should add 40 plus 70, we are going to get 110, then R minus X. We group like terms. S comes to the other side of the equal to sign. We maintain our 110. Our 100 also moves to the other side, becoming minus 100. So our S is equal to 10%, which means that both students or students that belongs to the two team or they play football and hockey at the same time is 10%. Then our 3-set problems. That's what SHS we are doing now. Let's go and start. Emily, you saw the diagram. You're asking yourself, what is this? Remember, it is the 2-set problems that we have already discussed. The addition of it is this. How do we go about this? You could see that for here, we have from region 1 to region 8. It is a bit different or complex than that of the 2-set problems. In the 2-set problem, we're having region 1, region 2, region 3, and region 4. But in 3-set problems, we are having region 1, region 2, region 3, region 4, region 5, region 6, and region 7. The last one, region 8. We could also see 3 circles. So therefore, we don't forget to our E, that's the universal set, the mother set of A and B and C is also there. Let's enroll. R1, that's region 1, is equal to A intersection B intersection C. R2, A intersection C intersection B complement, meaning both A and C only. So for region 2, we need members or elements that belongs to both A and C only. In region 3, we said B intersection C intersection A complement is equal to both B and C only, meaning members and elements belonging to both B and C only. In region 4, we have A intersection B intersection C complement is equal to both A and B only, meaning members or elements that belongs to both A and B only. We are also going to region 5. We have A intersection B complement and C complement is equal to A only, meaning members or elements that belongs to A only. Region 6, that's R6. B intersection A complement intersection C complement is equal to B only. What does it mean? It simply means members or elements that belongs to the set B only. R7, region 7. We have C intersection A complement intersection B complement is equal to C only, meaning elements or members that belongs to C only. Region 8, we have A union B union C all complement, meaning either A, B, nor C. Elements that do not belong to A, B, or C. So this is all about the 3-set problems from region 1 to region 8. We are about to take a question, and from this question will help us for you to understand the various regions of the 3-set problems. Don't be disturbed. Let's take it step by step. This is our question and a 3-set problem. In an examination organized by WAEC, each of 1,000 students sat for biology, chemistry, and physics. Each student passed at least one of the three subjects. 600 passed biology, 500 passed chemistry, and 290 passed physics. 175 passed both biology and chemistry. 150 passed both biology and chemistry. And 120 passed both chemistry and physics. How many students pass exactly one subject? How many students pass exactly two subjects? How many students passed all the three subjects? IV. Find the probability that a student selected from the candidates who sat for the exams passed all the three subjects. A nice and interesting question. Let's keep enrolling. Students, we write our solution. We select ye, meaning our mother set, that's the universal set. Student who sat for the exams, we said N standing for the number of students, that's the number of universal sets. E is equal to 1,000. That's what we have from the question. One of the data we have from the question. Let B, those who sat pass biology, that's NB, we get 600. Let's see those who pass chemistry, NC, we said 500. Let P, those who passed physics, NP is equal to 290. And that's students who pass in both biology and chemistry, that's B intersection C, is 175. And that's B intersection P, students who pass in biology and physics, is 150. Then N, students who passed in chemistry and physics, that's N, C intersection P, is equal to 120. Let S be those who passed all the three subjects, either that is A intersection B intersection P. Since in the question there, we could see that we were having three subjects that 1,000 students sat to rote. That's biology, chemistry, and physics. All the students at least participated or wrote the exams. But I want to know students who passed in all the three subjects. That's biology, chemistry, and physics. In the Venn diagram, our universal set is 1,000, not 100, sorry. Biology, students who wrote is 600. Chemistry, 500. Physics, 290. Remember, we said students who passed in biology and chemistry is 175. Students who passed in biology and physics is 150. Students who passed in chemistry and physics is 120. Since we are looking for x, we say that 150 minus x, 150 minus x, 120 minus x. B intersection C is where we have written 150, one of the region. Students who pass in both biology and physics, that's PB, we said it is 150 and it's also one of the regions there. Between chemistry and physics, we said it's 120 and it's also one of the region. where our X is centered in the middle, stands for all the students that pass the 3 subjects. So without wasting my time, we need to find for students who pass in only biology, students who pass in only chemistry, students who also pass in only phases, meaning B only, C only, then B only. It will be able, due to this, we will be able to solve for our questions. So let's carry on. Now, to be able to find for B only, it should be the total of students who sat for biology. We say 600. So 600 minus the 150 minus x minus x minus 150, 175 minus x. So 600 minus 150 plus x minus x minus 175 plus x. Remember we said positive will cancel negative, meaning plus x will cancel minus x. So our answer is going to be 275 plus x for students who passed in biology. That's 275 plus x. So we write it in the circle, B only. Let's go to that of chemistry. Finding for the number of students who pass in chemistry only. Since that 2 students who sat to write chemistry is 500, then in the circle there is going to be 500 minus 120 minus x minus x minus 175 minus x. Let's open bracket. 290 minus 120 plus x minus x minus 175 plus x. Positive will cancel negative, meaning plus x minus x will be 0, so they cancel each out. Now 290 minus 120 minus 175 plus x, we end up getting 205 plus x, and that's why we have it in our circle there. We are left with physics only. To calculate for physics only, it's going to be the number of P intersection C complement intersection B complement is equal to 290 minus 120 minus x minus bracket open 150 minus x bracket close minus x. 290 minus 120 plus x minus 150 plus x minus x. 20 plus x becomes our answer for students who passed or who sat for the physics paper. My students, we are not done. We've been able to find for the various regions that we have in the question. Remember, there is no complement since each student passed at least one subject. So here, we don't need our last region. We don't need it at all. Then let's see our answer. Since we are about to find for x, let's see our answer. The first question says, how many students pass at least all the 3 subjects? We said 1,000 is equal to, remember the universal set is 1,000. So 1,000 is equal to the individual regions. So 275 plus x bracket close plus bracket open 20 plus x plus bracket open 205 plus x bracket close plus x plus bracket open 150 minus x bracket close plus bracket open 120 minus x bracket close plus 175 minus x bracket close. 1000 is equal to 975 plus x. Since our calculator is helping us out, x is equal to 75. So my students, it simply means that out of the 1000 students, it is 55 students that pass in all the 3 subjects. They've really done well. It's not easy. Chemistry, biology, and physics. Let's go to our second question, which says, how many students pass at least 2 subjects? At least 2 subjects. Remember, we were being given some figures for students who pass biology and chemistry, biology and physics, chemistry and biology, chemistry and physics. So we go there, since in the question we're having minus x. So it's going to be 150 minus x, which is now x is what, 55, plus 175 minus s, which is now 55, plus 120 minus 55. Our calculator helps us for it to get our answer to be 280. Let's go to our I. How many students pass exactly one subject? Exactly one subject. So the individual regions, B only, C only, P only. We said 275 plus the x, which is 55, plus 20 plus 55, plus 205 plus 55. At the end, the answer becomes 665. Then the probability, last question, Ivan. We said probability of passing all the 3 subjects, the outcome over the success. Meaning, when we calculated for the student who passed all the 3 subjects, we had our x to be what? 55. So it's going to be the 55 over the total number of students who wrote the exams. So 55 over 1000. We can't leave our answer in a fraction form. We need to simplify. So we get our answer to be 0.055. Ladies and gentlemen, at this point, you've really enjoyed the class. I can't just leave you for the lesson to come to an end. So try your hands on this. Immediately you are done, send it to the platform or through our mail. Assignment for all students. Kindly participate. In a secondary school, there are 174 students in Form 2. Of these, 86 plays table tennis, 84 play football, and 94 plays volleyball. 30 plays table tennis and volleyball. 34 play volleyball and football. 42 plays table tennis and football. Each student plays at least one of the 3 games, and S students plays all the 3 games. A. Display these facts in a Venn diagram. B. Write down equation in X and hence find X. C. if a student is chosen at random from Form 2, what is the probability that he plays no game, or he plays 2 games? Sorry, he plays 2 games. Thank you very much for your time. We will be expecting you